Okay, some past HSC questions on 3D trigonometry, 1992 HSC, question 3A. Two yachts, so that's yacht A and yacht B, subtend an angle of 60 degrees at the base of a cliff. So this is the cliff. We can see here that the cliff is 100 meters high. So from yacht A, the angle of elevation of point P, which is on top of the cliff, so 100 meters vertically above C, is 20 degrees. So this is my angle of elevation triangle. And yacht B is 600 meters from C. That's what they've given us. They've given us this angle of elevation. They've given us this angle here on the ground. Okay, and the question is to calculate the length of AC and then the distance between the two yachts. This actually is quite an easy one, girls. This is an easy one. So you've got, this is a right angle triangle here. So this first one's quite easy. They don't make them this easy anymore. So what have we got? We've got this right angle triangle. This is 20 degrees. This is 100 meters. So the length of AC. So that one's quite fine. What are you going to use? I'll call it X. Sine, cos, or tan? Yeah. Tan of 20 degrees is opposite over hypotenuse. So this one's fine. This is easy. It's 100 over tan 20 because it doesn't have any bearings in it either, so it's quite easy, which is, so that's what AC is. And then you'll need the distance between the two yachts. So this one's very straightforward. Anyone got an answer? $274.7. I would, you know what, you may even keep some more decimal places, please, etc. All right, so we know that AC is that. Now, what you really could do, actually, instead of working that out, I'd like to use this opportunity because they often might say, instead of finding the distance between the two yachts, which is AB, they might ask you to show that AB is this expression. So I'm actually going to write AC as 100 over tan 20 because it keeps the answer exact. All right. Oh, it's probably not a bad idea to work it out, actually, because we're going to use cosine rule. So what else do we know? So that was 274. Actually, I'll get rid of it. It is 274.7477, etc. And this distance here, CV, is 600 meters, and they want the distance between the two yachts, which is AB. I'm going to call it little c. So c squared is, what rule? Two sides and the included angle. Cosine rule. C squared is a squared plus b squared minus 2ab cos of c. We know cos of c is an exact value. It's a half. Cos of 60. So it's 600 squared plus 274.7477 ... squared. Maybe keep that answer in your calculator. Minus 2 times 600 times 274.7477, etc. cos 60. Now we know that cos 60 is a half. So you can come up with an expression for c squared, and then we'll come up with an expression for c, which is AB. So therefore, the distance between the yachts, the distance AB is. The only time you might keep it as 100 over tan 20 would be if it was a right angle triangle and they were asking you for an expression for some other side, but only generally with a right angle triangle. Otherwise, it's just too hard to manipulate. So, girls, your answers should roughly have the same significant figures as your questions. And, you know, that's the yacht. I mean, it's 600 meters. They're just giving it to the nearest either 10 meters or 100 meters, whatever. So giving it to just a whole number would be fine to 3 significant figures. All right. So we get 520 meters. That question's fairly easy problem, but it doesn't involve bearings, so it won't be difficult. 1996 HSC question 4C, the figure shows the net of an oblique pyramid, and that's the base of the pyramid, and P, X, Z, YR, that's a straight line if you folded it all out. And PX obviously is the perpendicular height of this triangle when it gets pulled up. It's 15. RY, that's the perpendicular height of that one, is 20. AB is the length of the base. BC is the width of the base, 10. And we know that AP equals PD, so these are isosceles, that's an isosceles triangle. And BR equals RC, that's isosceles as well. And the net is folded so that P, Q, R, and S all fold up and meet at the apex T. Now we can see here what it folds up to be. And you might want to put some units on your diagram down the bottom. So, okay, T lies vertically above the point Z on the base. Now that point Z is not in the middle. It is definitely not in the middle of that base, okay? And the first question is to show that the triangle TXY is right angled. TX, really? Y. Must be right angled at the top because it would never be right angled at the bottom. It couldn't be because it's folding over. So let's put some measurements on. Have you started putting, you know that AB is 25. If AB is 25, so is DC. I'll write it on this side because if I write it over there, it gets lost. We know that BC is 10, so all of that's 10. You know that AP, where's AP? Guys, where's AP? Oh, that is actually AP. Because AP is, because they will meet at T. So that's 10. And we know that AP equals PD. That's actually 10 as well. This one. That's 10. Because that's that side, you know, that's that side folded up. See, AP and PD are 10, but because they meet at T, that actually is the point P. You know, T is actually the point P, Q, S, and R. It's all those 4 points. Because they meet, because that gets lifted up, Q gets lifted up to T, S gets lifted up to T, R gets lifted up to T. So the point T is actually point P, it's Q, it's R, and it's actually point S as well. So that's how you get AP equals PD. So they're both 10. We know that, what else do we have? PX. So PX, that's this. That's 15. This dotted one there is 15. Just be careful, that's that one. Now that's a perpendicular height. You know that's at right angles? That's the perpendicular height. If you look at the first one here, this is 15 here. It's probably easier to draw it on the original, you know. Draw it on the original. Draw all your measurements on the original. Correctly, BC is 10. That's that. So the bottom here is 10. That's 10. So these are not 10 here. But the bottom of this would be 10, wouldn't it? That would be 10. AD is 10. All right, so I think we've got some measurements on here now. Oh, yeah, it has to be because that's 10 as well. I think that's all the measurements on. All right, so show that TXY. T, oh, do we know this? We do. That's 20. All right, show that triangle TXY is right angled. Okay, I'd be drawing it if I were you. So, TXY. All right, I'll do it down here. So, let's draw a triangle TXY. I'm going to sort of draw it in the orientation that it is in. So, if this is X, this is T, this is Y, what is this distance, XT? 15, isn't it? And TY is 20. Do you know what the distance of XY is? Because if you see your diagram, XY is equal to AB, which equals DC, which equals 25. Those three are equal. You can already see it's a triad, but you'll use Pythagoras' theorem, of course, to show it. You don't just say it. So you'll just go 15 squared plus 20 squared is, I think it's 625. 25 squared is also 625. Therefore, 15 squared plus 20 squared is 25 squared. Therefore, triangle TXY is right angled. All good? So, if you're not sure what to do with part 2, it says, hence show that T is 12 centimetres above the base. Hence means Use your answer from part A or part 1 to do part B. So, show that T is 12 centimetres above the base. So, T going down to Z, you know Z is actually here, down there. That's where Z is. So, how do we do that? We basically want this, but we can't find that yet because we don't know what this is, right? We don't know what XZ is. Do know that this is an isosceles triangle, that equals that. We know that this one is as well. So this is the perpendicular height. If you look up here, look. If you go up here, that's 15, that's 10, that's 5, and that's 5. Because it's an isosceles triangle, right? Not saying we need that for this bit, but we know that that would be 5 and that would be 5. The only thing you could really work out here is this length. I need to find this height here. Now I've got this triangle here and I've got this triangle here. And I know that this is 20 and that that's 15 and the base is 25, which means that XZ plus YZ is 25, okay? So we know that in part B that XZ plus YZ equals 25. Now, it doesn't look like I can really do much else there. So what I'm going to do, I'm going to let XZ be, I don't know, whatever pronoun you want. What do you want to call it? Little a. So therefore YZ is 25 minus a. And I'm going to use Pythagoras' theorem in two triangles. In triangle TZX and TZY. Okay? Because I've got, and I'm going to call this H for height, the height, okay? So I'm going to draw two triangles now. Work, because I'm going to have two unknowns. So this is what I've got, TXZ, this is H. I'm going to call this A, and this is 15. And in my other right angle triangle, I've got 25 minus A, I've got 20, and this is also H, and this is TZY. Okay, so I'm going to draw, write up an expression for Pythagoras' theorem for each triangle. So I've got H squared plus A squared is 15, which means that H squared is 15 squared, sorry, H squared plus A squared is 15 squared. H squared is A squared, 15 squared minus A squared. And this one, H squared plus 25 minus A squared equals 20 squared. Pythagoras' theorem there. So H squared equals plus, might have to expand this one, 625 minus 50A plus A squared equals 400, which means that H squared equals negative A squared plus 50A minus 225, I'm thinking. And over here, H squared is 225 minus A squared. Now you can put those two equal to each other, come up with a quadratic and solve for A. And when we solve for A, we can then solve for H. Okay? So, I think my maths is correct. So solving simultaneously, so therefore negative A squared plus 5A minus, no, it's 50A, isn't it? Plus 50A minus 225 equals 225 minus A squared. Probably should have done it the other way around. Sorry, I should have written it the other way around. Doesn't matter. So going back to the other side, 2A squared minus 50A, got it? Plus 225 equals 0. And then, no, I've gone to this side. Oh, it's plus 450, isn't it? Plus 450. Oh yeah, they do too. Very good. Oh dear, sorry. A squared, don't know what's wrong with me, cancel out. So 50A equals, what's that, 450? A is 9. Yay. And if A is 9, so therefore A squared looks to be 15 squared minus, sorry, H squared. H squared we know is 15 squared minus A squared. So H squared is 15 squared minus 9 squared, which is, you can see it's a triad. It's 16. H is 16. H squared is it 196? No, it's not. 1 what? Oh, so is it 12? What's wrong with me? Sorry. It's 144, sorry, which is 12. Bad day, bad day. Sorry. Dear, don't make my mistakes. Show all your working. Oh, yeah. It's a triad of 3, 4, 5, and that's the 3 side and the 5 side. So the other one's the 4 side. So H is 12. So now that we know that H is 12, it says find the angle that the face DCT, so this face, makes with the base. Now, that angle is going to be, this is, let's say this is the face DCT, right? DCT. This is the face. If I want the angle that this makes with the face, I need the angle from there down to the bottom. All right? But is that the same if I put that angle from inside here to the bottom, if I put a line straight down the center of this shape, straight down to the bottom, and draw like this. So where this pen is, if I do a line from the apex down to the tip of that blue pen across there and up here, I think that angle sitting in that corner should be the same as that angle as well. But maybe this one's the safest one because all the, you know what, because all the faces are sloped slightly differently. They're all leaning over a different amount. So I think maybe we'll go with this one. All right. Or, just seeing it now. So if this is 12 and this is 5 and I draw a diagonal here, here's another right angle triangle. I'll do it in another color. All right, here I'm doing this in another color. So I've got this bit here is 5. This is a right angle, and this bit is actually the perpendicular height of DCT of that face. Can you see that triangle in there? So in that triangle there, this is what I've got. I've got 12. This is T, Z, whatever that point is. Right? This is 12, and this is 5. Because that's 5. And so is that. Okay? And I just need this angle here, theta. I need this angle in here. Yeah. Okay, so can you see it now? So tan of theta is 12 over 5. Theta is tan to the minus 1 of 12 on 5, which is? Anyone? 67 degrees and? Another way to do part B, show that T is 12 centimeters above the base. There is another method apart from our simultaneous equation method. So another method is as follows. Because we had to show that triangle TXY was right angled, I'm going to draw that up here. TXY. I know I'll call this angle theta. I know that that was 20, 15, and that this is 25. So I'm going to call this angle theta. Here is triangle TXY. I know this is a right angle up the top. So, but I also have another right angle triangle in here. So I'm also going to draw right angle triangle TXZ. And this is angle theta as well. And this is 15. And I'm going to call this H, right? So what I can do is, according to the second triangle, I need sine theta. So sine theta is H on 15. But I can actually work out what sine theta is from the top triangle. So in the top triangle, sine theta is opposite over a hypotenuse, which is 20 over 25, which is 4/5. That's what sine theta is. And in the bottom triangle, sine theta is H on 15. So I know sine theta is 4/5, so 4/5 is h on 15. And so therefore h is, I can see 5 times 3 is 15. It'll be 4 times 3, which is 12. And that is another method of doing it. Okay? Method to work out h. If you use that first triangle, in triangle TXY, the area of triangle TXY is half base height, which is half of 15 times 20, because they're at right angles to each other, which is 150 centimeters squared. But you could find, so we know that the area of that triangle is 150 centimeters squared, but you can look at the area of the triangle this way. Also, the area of triangle TXY is a half times whatever XY is times that TZ, which I'm calling H. Do you get that? So we can do the area of this triangle like this, half of 15 times 20, to get that. But you can also find the area of that right angle triangle as follows. This is H and the base is 25. So it's a half of 25 times H. We know that the area is 150. So, yes, so it's 150 divided by 12.5 is what H will be. Or 250 divided by 25 actually. No, 300 divided by 25, whatever. Well, half of 25 is 12.5. So we get that H is also 12 that way. So you've been shown 3 ways to find H, and the very first way was the most complicated. But, you know, it's probably the one that would come to you first anyway. But now you can think of trig as a second way and area as a third way. All right? So 2000 HSC question 3C, sorry. Okay, a surveyor stands at point A, which is due south. Now, all right, of tower T, excuse me, there is something in here that's really important. You might look, here is the tower, everyone. When your tower is due north or due south of something, this is the north line. This dotted line, this is very important, is north. So whenever you're talking about something due north or due south and we're talking about a 3D trig problem, you have to draw your north on a 45-degree angle. Otherwise, see, how can I go like this? Otherwise, it looks silly. If I've got north here and then something else is due south of it, I can't then show the angle of elevation to it. So it's really important here. So what happens is you must draw north on a 45-degree angle, and your east must run horizontal. So this is a right angle. Okay? So you will sometimes get diagrams that look like this, where north, and this will happen when something is due south or due north of something else. So you must draw north on roughly a 45-degree angle. But you must put your right angle in. See how I do my right angle? So it's parallel with that and parallel with this. And then it looks like a right angle. Is due east? Well, I'm not sure. Yes, see, this is due east. So north, if this is due north, this is south down here. Do you see it? Otherwise, you can't draw the angle of elevation up there. If I do it like this, how am I now going to do an angle of elevation from here up to there? You can't. You can't show it in 3 dimensions. So whenever you've got a 3D problem where they're talking about north, south, and east, west, you must draw north on a 45-degree angle. Now, it is drawn for you, and they probably pretty much will do it. Okay, so a surveyor stands at point A, which is due south of tower OT. See, this is the tower in the air. That's the tower. It's got height H, and he's due south. If this is a north-south line, he is due south. Can you see he's running on that line? If I did it like this, I can't do this. How can I do this? And then do the angle of elevation to there? I can't. Do you see? Okay. So, height H meters. The angle of elevation of the top of the tower from A is 45 degrees. And the surveyor then walks 100 meters due east. So the surveyor had to start here and then walks due east. So this is my east line. This is east. We okay with that? Due east to B. From where she measures the angle of elevation to the top of the tower to be 30 degrees. Okay, so that's really, really important. This north being on a 45-degree angle. Okay, now, first question is to express OB, the length of OB in terms of H. So let's have a look at that. B in terms of H, OB in terms of H. Draw that right angle triangle separately. It's your angle of elevation triangle. It's going to be, if I want OB and H, that's tan. Tan of 30 degrees is, what is it? H over OB. So therefore OB equals H over tan 30. What's tan 30 equal to? So it's H times 1 times root 3, because it's 1 over root 3. Are you okay with that? It's really H divided by 1 over root 3, which is root 3 times H. It's root 3H. You know, you could write it as, instead of like that, why don't you write it as H cot 30, because it's 1 over 10. You might go, sorry about this thing, it's really H cot 30. Do you see that? And cot 30 is root 3, so it's root 3H. And you have to show that H is 50 root 2. Now, they'll always guide you. Now that you've done that in this angle of elevation triangle, because H is also common in the other angle of elevation triangle, for part 2 you need to do exactly the same as you did in part 1, but using the other triangle, TOA. Angle of elevation is 45 degrees. That should, you know, the tan of 45 is well, sine of 45 is 1 and root 2. Tan of 45 is 1. Let's just see what we've got with this root 2, but it could be something else that happens. So let's just do the same thing again. Actually, it's going to be with the bottom triangle. Because we just found an expression for OB in terms of H, let's find an expression. We always want lengths on the ground, all right? Let's find an expression for OA. So we're going to find OA in terms of H as well. We're just going to do the same thing. If you do it on this triangle, find OB, you will do it on the other side to find OA. You always do that pretty much. So the tan of 45 degrees is H over OA. So OA is H over tan 45. What does tan 45 equal? 1. So OA equals H over 1, which is H. Now we're in the bottom triangle, which is great because we've got a right angle there. So let's do our ground triangle. So now we're going to look at our ground level triangle, and I'm looking at the diagram there, and luckily they've put the right angle there, but we should know that from over here because we've got north and east. So that is a right angle. So I'm drawing my ground triangle like this, and I can draw it flat. It doesn't have to be on an angle. You do not need to draw the ground triangle three-dimensionally anymore. The only time you need to draw the ground triangle with 3 dimensions is in your original diagram. Now I say my ground triangle, I have an expression for OA, it's H. I know that OB is root 3H, isn't that right? Sorry, OB is root 3H. And what's the distance of AB? Given in the question. It's 100. Now I can just use Pythagoras' theorem to find H. So H squared plus 100 squared equals, in brackets, root 3H squared. So H squared plus 100 squared is 3H squared. Doesn't that mean that 2H squared is 10,000? H squared is 5,000. H is the square root of 5,000, which is, now look at the answer, 50 root 2. What's 50 times 50? 2,500 times 2. Square root of 2,500 times 2, which is 50 root 2, isn't it? 50 times 50 is 2,500. Okay? The last part is to calculate the bearing of B from the base of the tower. The bearing of B, the direction of B from the base of the tower. Those bearings are measured on the ground. Now, tricky here. Can you see that this is AOB? I've got a right angle here. This is north, right? I'm going to put this other diagram next to it, ladies. Now looking here how I've got AO and north continues up there, north continues up here. Okay, north is up here. Can you see that? AO north. AO, that's north. So I'm going to draw this diagram again. Here's my triangle. I need the bearing of B from the base of the tower. I need this diagram. I need that angle there. AO north. The direction of B, the base of the tower is O. Can you see that there? The base of the tower is O. So I need this angle here, but it's actually that. Because remember, that's drawn obliquely, the first diagram. That first diagram doesn't really show you things properly. Now what we're going to do, we know what H is. This is H, 50 root 2. This one is 50 root 2 times root 3. Are we okay with that? And this is 100. Now, if I need this angle here, why don't I just find this angle there and do 180 minus? Now, I won't use this. I don't need this. See, it doesn't matter that you couldn't do this. You could have still, oh no, it does. So, but that's why it says show that H is 50 root 2. So even if you couldn't do it, you can still do the next part. So when I do tan of theta is 100 over 50 root 2. Tan of theta, isn't that 2 on root 2? So theta is inverse tan of 2 on root 2. Sorry, I'm off page. Well, we don't know what tan of, the root 2 ones are the sine. 2 on root 2, you know, is just root 2. Because 2 is root 2 squared over root 2, which is root 2. So theta is inverse tan of root 2, which is 54. And so therefore the bearing is 180 minus 54 degrees 44 minutes. 125 degrees, but bearings are always 3 figures. 125 T, true bearing.